Hello friends, let us solve one more gate problem, and the question goes like this. So we have two signals x of n and y of n which are defined here, and their Fourier transforms are x of e power j omega and y of e power j omega. So let us write down what is given for a signal x of n, which is here. Let us not write that, we'll just we have Fourier transform to be x of e power j omega, and for the signal y of n the Fourier transform is given to be y of e power j omega, and we are asked to evaluate this integral. Okay, so in that integral, if you see, we have two terms, x of e power j omega and y of e power minus j omega. So by using time reversal property, what happens for which signal will have y of e power minus j omega as the Fourier transform? That would be y of minus n. Okay, right. So what is happening in frequency domain? These two terms are getting multiplied. So x of e power j omega and y of e power minus j omega are getting multiplied. So that is x of e power j omega multiplied with y of e power minus j omega. Because they are getting multiplied in frequency domain, what will happen in time domain? The corresponding signals, which are x of n and y of minus n, they will get convolved with each other. So let us call this to be z of n. Okay, so sorry for that. Okay, I'll write that down here. So let us call x of n convolved with y of minus n to be equal to z of n, and that fellow will have what as Fourier transform? We have z of e power j omega, which is nothing but x of e power j omega multiplied with y of e power minus j omega. But what is the question asked? The question asked is we have to evaluate 1 by 2 pi integral 0 to 2 pi x of e power j omega multiplied with y of e power minus j omega d omega. We can easily see that this is nothing but z of 0. Okay, so that is nothing but our z of 0. So everything boils down to what? Evaluating z of n and then evaluating z of n at n equal to 0. Okay, so question is we have to evaluate this integral, and we have found that this integral is nothing but the value of z of n at n equal to 0. But what is z of n? Z of n is nothing but the signals x of n and y of minus n convolved with each other. So if you remember signals and systems class, especially the LTA systems topic, so we see that this is nothing but cross correlation between the two signals x of n and y of n, and we have seen that that is nothing but x of n plus k summation k equal to minus infinity to infinity x of n plus k multiplied with y of k. But we are interested in evaluating what? Z of 0. So what will happen to the z of 0? That would be equal to summation k equal to minus infinity to infinity. Wherever there is n, substitute with 0, you get x of k times y of k. So let us substitute what is given. So this summation would be k equal to minus infinity to infinity. What is x of k? X of n is given. So we want x of k. Wherever there is n, replace with k. So you get 2 power k minus 1 u of minus k plus 2, and this fellow is multiplied with y of k. What is y of k? Y of n is given. We want y of k. Wherever there is n, replace with k. So you get 2 power minus k plus 2 multiplied with u of k plus 1. Okay, so because you have 2 power k and 2 power minus k, they will get cancelled out, and we have 2 power minus 1 multiplied with 2 power 2, which will become 2. So finally this summation boils down to 2 times summation k equal to minus infinity to infinity u of minus k plus 2 multiplied with u of k plus 1. So let us try to plot these signals one by one. So what is u of k plus 2? That is a unit step function. First shift to the left by 2 units and then do the time reversal. So how does the plot look for u of k plus 1? So the plot u of k is unit step function from 0 to infinity, so shift that to the left by 2 units and then do the time reversal. So finally the plot will look like this. Okay, so this is our u of minus k plus 2. We want u of k plus 1, so this is 1 0 minus 1 and so on. And what is u of k plus 1? That is unit step function from minus 1 to infinity. So it looks like this. So the amplitude is 1, here also amplitude is 1. So if you multiply these two signals, how does the plot look? So the overall signal will exist from where to where? Minus 1 to plus 2. So before minus 1 the product is 0, after 2 product is 0, and if you look at the amplitude of each sample it's all 1. So if you multiply, what happens? So you will have a signal which is of this form. You have impulses from minus 1 to 2 each with amplitude 1. So that is nothing but, so this is our u of k plus 1. So if you multiply these two signals, the final product will look like this. Okay, but we want to evaluate the summation of all the samples. So that turns out to be 2 times how many samples are there? We have 4 samples from minus 1 to 2, which is all with all amplitudes 1. So if you sum all of them, you get 1 plus 1 plus 1, which would be equal to 8. So in that way we can evaluate this problem. Hope you have understood the concept. Thank you.